Hey, all right, welcome back, everyone. I am Jeremy Daly, and this is another Ampt live stream. We are live on Twitch, and I got some feedback here. Sorry, we're live on Twitch and on LinkedIn, and what else? Twitter, X, and YouTube. So go check us out. Hopefully, you're there. Would love to have you jump in with some comments if you would like to do that. So anyways, again, I'm Jeremy Daly. I'm one of the founders here at Ampt. If you're not familiar with Ampt, it is essentially a self-provisioning runtime for AWS. That is the best way to explain it. So it is not a PaaS. It runs within AWS. It basically takes your application code and it uses a runtime that we developed on top of Node. Runs on top of Node 18 or Node 20 right now, and it analyzes your code and it automatically deploys all the infrastructure that you need. It's completely deterministic. It is very, very cool. It is super easy to work with. It's very different than a lot of other things out there, but there's a bunch of cool things you can do with it. Let's go ahead and just build something. So the other day, I was on a live stream for the Believe in Serverless community, which, by the way, if you have not checked this out, if I can spell right, believeinserverless.com. I guess I spelled that right. Believeinserverless.com. So they have a Discord. They have a whole bunch of people that are in there, all people dealing or working in the serverless space. Very, very cool stuff. They get a bunch of live streams that they do every single week. A bunch of really great people involved in this. So go check that out. But I did a live stream with them last week, and we were playing around with Claude Sonnet, and we were trying to do a meme generator. And I ran into a couple of problems. The Stable Diffusion was out of the old Stable Diffusion v0.8 was deprecated, and we hadn't updated some things yet. So anyways, we ran into a couple of problems, and it was a really interesting use case. But then during that conversation, there was even a better use case that kind of came up, and that was the idea of using a vision API or a vision model in order to describe an image so that, again, whether it was for people with sight issues or things like that, that they could actually, that you could use those for describing an image that was sucked into the system or was on a web page or something like that. Obviously, there's all kinds of tools and services like that. But if you're building your own website, or maybe it's whatever you're doing, right? Whatever you're doing, where you're publishing images somewhere, having those alt descriptions and being able to describe what those images are, so that screen readers can pick those up and can accurately describe those images, it's a pretty big win. So it's something that would be nice to just kind of take care of, because I know for me, I always think I'm like, just got to do some alt text or whatever, and you try to describe the image, and it's not usually helpful because you're not going to put the time and energy into it. So, anyways, what if we had the magic of AI and that could do that for us? All right, so let's start here quickly, just talking about what exactly we want to build. So there's a couple different ways we could do these workflows. I'll start by just sort of showing the connection into Amazon Bedrock or Amazon Bedrock through through a Ampt application, and then we'll kind of go from there, and we'll play around with a couple of other things. So let me do this. So let me go over here, and I'm going to create a new. I'm going to try to, there we go. So here's a new Visual Studio Code. I'm going to go ahead and open up the terminal here, and I will cd into my git/sandbox directory. This is just a local directory on my machine. I'm going to make a new directory called, let's call this alt generator. How about that? And then we will cd into alt generator, like that. Okay, so now we should just have an empty directory on our machine here, and we're going to go ahead and type in Ampt. Now, what Ampt is going to do is, this is the Ampt CLI. I'm going to select the demo organization here. Do I want to create a new app? Yes, I do. And then I'm just going to go ahead and select Hono, because again, I select Hono for pretty much everything at this point. It's just such a great It's just a great framework for building all kinds of stuff, type safe, TypeScript friendly, all kinds of things. So anyways, we're going to name this alt generator. And would I like to use the current directory? Yes, I would. I'll actually open up this directory. Oh, we haven't seen that yet. So hold on a second. So this is generating a bunch of files. So while this is doing this, I should have CD'd into that directory so that, or sorry, not CD'd, but should have opened the code in that directory. So essentially what this is doing though is this is just generating a bunch of files in this directory for us. I'm going to exit out of, oops, go back over here. Going to exit out of Ampt, type it correctly, and I'm just going to type in code dot, and that's going to go ahead and open this back up so that I'm in this current directory. I don't want to reopen any container, but one of the things we do with our dev or with our templates is we do give you a dev container and a gitpod.yaml so that if you wanted to open those in one of the web IDEs, either Codespaces or Gitpod, you can do that. Okay, so here are the files that it generated for us. Pretty straightforward. There is, again, this git ignore, this gitpod, which we're going to just remove this so we don't need to see this. So we've got an index.ts file. We got a package.json. Package.json basically just says, a little bigger. Actually, I'm going to make this a little smaller so that we can read more. So this is, again, just is describing what the template is. This is just, your standard package.json. We can go ahead and rename this if we want to. If we want to clean this up a little bit, we'll call this, what are we at? Alt generator, like that. And then we'll just say this is an Ampt app that generates alt text from images, like that. And then this points to main, which is just index.ts, is just our entry point. We got a couple of sample scripts here. Again, we don't need this gitpod one, so we'll get rid of that. And then it just says the Ampt SDK and Hono installed, and then we have our app and org name as part of this. So I'm going to save this and close this because I always do that where I'll leave my JSON, my package.json file open, and then I'll make some changes via the command line, and then it'll mess everything up. So anyway, so that's saved. We're good to go there. So let's just take a quick look at what we actually have set up here. So I'm going to run the amp command again. So this app is already created. It reads the JSON package or the package.json file. It knows where it's supposed to point and which application we're working on, which ones I have permission to, and so forth. So this gave me this URL. I'm going to go ahead and let's go over here. I'm going to go ahead and open this URL. And this is going to load this solid-deploy, yada, whatever, amp.app. This is essentially loading my remote sandbox. This is my isolated sandbox running in AWS on a completely isolated account. And this is instantaneously synced with what happens here. So again, if I'm repeating myself, if this is the first time you're watching, I'll show you the workflow pretty quickly here. But essentially we have this static folder. Anything in the static folder automatically gets mapped to a manifest and shipped to the edge, and it automatically loads. It's very, very cool stuff. It goes really fast, but just to show you quickly how this works. So this is just a regular HTML file. If I was to delete, I'm going to delete all this stuff right here. And I'm just going to say hello from Ampt, like this. Watch that little thunderbolt there. As soon as I click save, that goes ahead and turns into a check mark, and I refresh this, and this is immediately updated. So this happens very, very fast. The point of this is, again, so that you can make changes locally, and those changes sync instantaneously, and you can test them against real cloud resources. Now, we're not using anything other than just static right there, so let's actually go into this index file, and we'll see that this creates a Hono app for us with a hello route. So if I go here and type hello, like this will go ahead and give me this hello. And again, if I were to make a change here and I were to say hello from Ampt with an exclamation, I save, I sync, I refresh, and it's immediately available. So that's how fast it is. That's how fast the workflow is. This is true for storage and data and all the other modules and interfaces that we support as part of Ampt. Okay, so that's how that works. Let's go back and actually do something. So again, this is just a regular Hono app. I would suggest learning about Hono because it is very, very cool. There's a lot of things that we can do here. All we have to do in order to make Hono work with Ampt is just put this in the index file or whatever your entry point file is, and then just call this app.fire, which is Hono's way of triggering an add event listener for you because of the way that Ampt's runtime works. It uses the fetch-based listener in order to do the routing. So just like Elysia or Bun or some of the Elysia, which runs on Bun, but again, same idea, right? Where it's more of a web standards based approach. Okay, so I'm going to save that. So we just have a single route there. So what we want to actually do now is let's bring in some AI so that we can actually start using it. So we'll use the interface here as we'll use an API, the web framework here, Hono, in order to do the initial testing. But there's all other kinds of ways that you can do testing. You can run scripts locally that trigger things and interact with remote services, all within an Ampt context. There's a bunch of videos on that if you want to go check out our YouTube channel. They're all posted there. All right. So if we want to use Ampt in order to actually build something with Bedrock, we want to interact with all these different models. Again, this is running directly on AWS. So anything that runs on AWS, you have access to via Ampt. So I'm going to go in here to the docs, and I'm going to go to this Ampt AI module here. So essentially what this does is this provides a wrapper on top of Bedrock. So it just does a couple of handy things for you. So let me make this a little bit bigger. So it gives you like a chat interface where rather than you having to call and invoke the model directly, this normalizes it so you can use a bunch of different models in order to do the chat stuff, and you don't have to change the way the interface works, and you have to change the way that the output works, which is something that you'll notice if you call like Claude models versus calling, like the Llama models. Some of these other things, those are Llama. The Llama models, they're a little bit different in terms of how the output works. When you use this chat interface, it normalizes that for you. So it just makes it a little bit easier. Same thing with the render. So render right now only supports the Stable Diffusion V1 or V2, I think it is at this point, right? We just upgraded it. So yeah, XL V1. So, but we are going to add support for the Titan model, for the Titan image model as well. It's a little bit different in terms of the interface for it. So again, normalizing some of these things isn't as easy as we would like it to be. But we do have some other features too, like summarize, which will use different models in order to do the summarization. Translate, actually just a handy feature. This just sends it to Amazon Translate because it actually works really, really well, and is actually less expensive than using something like one of the Anthropic models or the Llama models, or even the AWS models. And then if you want to generate embeddings, so embeddings had support for Titan V1 and the two Cohere ones. So we've added the newest one, which is the V2 Titan embed, so you can go ahead and create your embeddings if you want to maintain your own vector database and you want to create those embeddings, you can do all that. So there's a bunch of nice shortcut things that you can do. These models are getting more powerful. There's more things that you can play around with. There's more interfaces, different options and things that you can do. And we always support this invoke interface. And essentially what this invoke interface is just the standard. It's basically just passing it right through to the invoke endpoint within the Amazon SDK for Bedrock. What this does do, though, is this automatically selects between, if the model supports streaming, then it automatically returns a streaming response or a readable stream. So you don't have to switch between those two. Actually would love to hear some feedback on that because I've had a couple of use cases. One of the things on the show today is that sometimes you almost want to just get that text back and you don't necessarily want that readable stream, because I'll show you today what I'm going to build. We're going to actually convert the readable stream back to regular text in order to save that into a database. So that's just something, again, we were trying to make this super easy and trying to find the right level of abstraction, but always love to hear everyone's feedback. So, okay, so in order to use this, essentially it tells us right up top, or it should tell us right up top, that we just need to make sure that we have, go back up here, make sure that we are on node 20 or node 18. We automatically are. When we create a new app, we're automatically on node 20 now. And then it says that we have to bring in one of these interfaces from the Ampt AI module. So we're going to use the invoke here. And doesn't quite say this, but says the invoke interface is used to send a raw request to the underlying AI model and receive a response. So let's go over here, and we're just going to do import what do we want? We wanted invoke from @ampt/AI. We don't have this package installed yet, so we'll go ahead and install it. /AI, like that. Okay, and now we got to do some coding. So this should be there now. Okay, so now we have this. So in this hello route, I'm going to leave the hello route for now, and I'll create a new route, and we're just going to call this, I'm just going to call this test. It's going to be super, super helpful here. So we now have a new route. Again, if I jump back over to here and I type in /test, we're going to get the same exact response here, hello from Ampt, because I haven't changed that yet. And so now what we want to do is actually do something with this invoke. All right, so in order to invoke this, again, this basically says it accepts a single object with the following properties: body, content type, accept, model ID, so forth. You don't have to worry about encoding the body. Like we do a bunch of things for you that's pretty straightforward. So you just have to, you don't have to worry about JSON stringifying the body, which is typically what the model requires you to do. So let's just go ahead and do something. And by the way, we added a bunch of models too. So there's like a ton of models now. We don't support all of them. They're like still the image ones, and then some of the cohere ones for, I think it's R or whatever they are. Those aren't supported yet through here, just because the way that those models interact, we haven't quite got that set up yet. So, but the Titan models, those are all available, including the Express, Lite, and Premiere. They're not available via this chat interface yet. We haven't done that because, again, the response is that normalizing things, but you can use them through the invoke method. So, all right, so here's what we're going to do. Let's go ahead and create an invoke method, and we need to make sure that we use a model because we are going to be reading in images and doing something with that. We want to make sure that we use a model that has vision capability. So let's go over to Amazon Bedrock for a second here. Not Bedrock, Bedrock. And let's go into, let's see here. We'll go into, see if we can find anything here. Facts, testimonials, overview, features, pricing, resources. Let's try this. How do we do Amazon Bedrock documentation? How about that? Let's see if we can find that. Amazon Bedrock. What is Amazon Bedrock? Okay, here's the user guide. Here we go. All right, so here's the user guide. I'm gonna make it a little bit smaller. Hopefully that's not too small. Okay, so over here you have this foundational model information, and this will give us the foundational models that are available. I make it even smaller, sorry. Hopefully that's not too small for you to see. So you've got the Anthropic ones, the Amazon ones, the Cohere ones, and so forth, and it tells you the input modalities and the output modalities. And the output modality that we're looking for is either text or chat. It doesn't matter. We just need an output. But the input is the important one. So we need to make sure that we can send it images. So if you look here, the only ones that support images are the Anthropic ones, and then the Stability AI. But again, this isn't going to give us what we want because we want a text output. So our options here are to use Sonnet, Haiku, or Opus. That are through Anthropic, all Claude 3 models. The difference in them is, yes, there's probably going to be some quality. There's going to be some speed. Haiku is very, very fast and extremely inexpensive. Sonnet is sort of the mid-level one, and Opus is like the crazy one. So the other thing that you can always look at, too, when you're evaluating these models is not just whether or not they work really well. I did not spell pricing right. Whether they work really well, but also just around the cost, right? So if we come down and we look at the Anthropic models, for example, if I can find them, Amazon, A1 Labs, Anthropic, right? So your Opus for the number of tokens, and again, if you're doing some stuff with AI, learn about tokens and some of these other things. Like, these are really cool. I mean, like knowing some of this stuff is super helpful so that you can kind of estimate some of this stuff. So it's not one-to-one, but roughly 1 word per token is probably a good way to kind of estimate things in your head. So depending on how many words you need to describe something or how many words you're entering versus how many words you're getting back out is your input versus output tokens. There's also some pricing around images, the way that they do that when you're sending an image in. I think it tokenizes the base 64, and that counts as a certain amount that you're putting in. But anyways, just from a pricing standpoint, so this Opus is basically 1.5 cent cents for every 1,000 input tokens, whereas Haiku is 0.00025 cents USD. And Claude Sonnet is somewhere in the middle there, right? About, I guess, what, a fifth of the price or so of whatever this is there. So 3 times 5, fifth, something like that. Whatever, then my math is probably wrong. But so much cheaper to use one of these models, Sonnet or Haiku, versus versus using Opus or I guess versus using Opus. So, all right. So the supported foundational models, again, we'll go back to this. So let's use Sonnet because it's kind of in the middle, and that should be pretty helpful for us. So click over on the link here, and this is going to explain. I'm going to make this smaller again. This is going to explain exactly how you need to do the input. Now, again, we are doing a raw input into the Invoke or Invoke with streaming on Bedrock. So we need to follow this documentation, which is also helpful, right? We're not trying to do anything fancy here. We're just trying to make life easier with some of this stuff. So there's 2 different models for it, text completion or messages API. We're going to use the messages API. So click into that. And this is just going to give you the overview and essentially say, we don't have to go through all of this, but essentially what you do is you send in messages, right? And you send in an array of messages with a role of user whenever it's a user that's sending in the message with whatever content you want to send in. And then you can maintain the conversation by basically taking whatever the assistant says and put that in the content of an assistant role and then go back and forth. And then that entire chat history will maintain the context window for you. Yes, great, okay. So we need to do something like that. Then you have this option to do system prompts, which is super helpful. So system prompt is essentially a way that you can send some information into the model that it sort of prioritizes above everything else. And says things like, that again, in this instance, you're Claude, you're an AI assistant created by Anthropic to be helpful, harmless, and honest. So you can say like, you're a DevOps engineer, name Jim, and you're helping people answer complex questions on blah, blah. So you could give it a bunch of that context for every query that you send in, which is usually pretty helpful because, again, then it sort of sets some context for the model and will change the way that it kind of responds. All right, so then the multimodal prompts, what we want to try to do here is, or what this does is this allows you to actually send in an image into, as one of the prompts, and then you can actually tell it to do something within, with that image, what's in these images, describe the image, whatever you want to do. So that's pretty cool. So again, all you have to do is just basically say that you want it to be an image, and then you send the source in as the type, the media type, and then the data in base 64 format. All right, tells you what you can do. Here are the models that support some different things, and then it gives you the requests and response. So this is exactly what we need to send into the model. We need to send in the Anthropic version. We need to send in the maximum tokens. We need to send in the system prompt. We don't have to, but that's an option. The messages, right? So the role, the content, and so forth. And then we have the option to send in the temperature, the top P, and the top K, and then the stop sequences. So there's a whole bunch of stuff that you can learn around this. Again, the temperature is like the how random, like is the randomness piece of it, I believe. The top P is well, probably tells us somewhere here, right? Top P, yeah. So temperature is the amount of randomness. Top P is the nucleus sampling, which I believe is like the amount of words that it will choose from. And then the top, or maybe it's the other way around. The top K is the only sample for top K options. So I think top K is the number of words. Anyways, you can play around with those things and tweak the model that way. That's all next steps for us. Okay, so what we have to do is we do need to grab this particular request here and figure out how we want to actually put this into the system. So I'm going to copy this directly just for now. And over here, before I output anything, we'll worry about that in a second. We are going to go ahead and do, let's do const, and we'll say response. And it already is doing invoke for us, so we'll do invoke like this, and we should be able to just send in this thing here. Let me save and get this formatted. Okay, so Anthropic version, object globally known version does not exist in type invoke options. Okay, hold on a second. Let me just, I have notes because again, I like to make sure Oh, sorry, I lost my mouse here for a second. Where did it go? So I have like 4 screens here, including one of these. All right, it's stuck on my iPad for some reason. Here we go. That work? Okay. I guess it extends that way. All right, so where were we? So we need to call this invoke. No, this is right. So we invoke. I must just be doing. Oh, because we have to await this, and that means we have to make this async, like this. Okay. So we're gonna invoke, await, invoke. That should be right. And then we have to send. Sorry, this is the body. So that's what we have to do. Okay, so we got to send this in as the body, like this, and I'm gonna make this. Actually, I'm gonna move the. I'll leave it there for now. Okay, so this is the body, and as soon as I add in another thing down here and save it, it should format it and maybe make it look better for me. Why is this angry with me? Invoke. I love when this stuff happens. Okay, here's what we're going to try to do. Get rid of all this extra stuff for now. Oh, you know what it is? I bet you it's all this. It's this. Okay, this probably doesn't like this. Okay, so 2048. Probably spelled that right. 2048 and... Oh, because we're missing, okay, so we're just missing stuff. All right, that's why. All right, so that's the body. So we need the body. And then if we go back and we look at our thing here, so we need the body, the content type, we need the model ID. So let's put the model ID. This might overload. Yeah, okay, so that gave us what we needed. Okay, so the model ID that we're gonna use is we're gonna use the, let's see, Sonnet here. So I'll copy this. And we'll paste this in like that. Okay, so, all right, we're getting there. All right, so the model ID, the accepts, and so this stuff here, by the way, this content type and accept, this automatically defaults to application JSON, so we don't actually have to put that in. All right, and the other thing that we had to do is if we go back to this here, we do have to send in the messages. So actually, I'm gonna go up here, I'm gonna copy these messages like this because this is an actual example for me. So let's get rid of system for now, copy in messages and clean this up. So this is, okay. All right, so type is going to be an image, source is going to be, I guess I could use these fancy things here, but I guess it's not going to help me much in the short term. All right, get rid of that, get rid of this, get rid of this. It's like a lazy programmer. I could have typed this faster if I just would have typed it. Text. Okay, all right, so what I'm going to do first is, so this now should invoke this model for us, and it's going to send in, obviously there's no image here yet. This is just a short example. But what I can do is I can actually we'll send in a different message to see what it does. So this will go ahead and respond with the response, and the response is returned as a readable stream. Right, so it gives you a readable stream that contains the model response, and so I can go now and just say return c.body. And then we're going to return the response. This is a readable stream, so we need the response.body. And I think that should work. We're just going to test it. But what I'm going to do first is I'm going to comment this out, which it's yelling at me for because I didn't comment that out. And then rather than say what's in these images, I'm just going to say Tell me a story about a dragon and a knight. Sure, in 2 sentences. We'll make this quick. All right, 2 sentences, save. All right, so we've now created this endpoint that says test. Let's go ahead and we'll just call this, I'm going to call this generate, just for heck of it. And this should invoke the model through Bedrock. With this prompt, tell me a story about a dragon and a knight in 2 sentences, using this particular Claude 3 Sonnet model, and then it should stream those results back to me. Those might not stream because we might need to chunk it, but you're going to see this is going to give us sort of a weird response because of the way that these Claude models work. All right, so I refresh this. Test will not be found, so let me change this to generate, like this, and this should generate a response for me, and it does. Okay, so what you'll notice here is, this is what was screwing me up the other day. So this is the response that you get back from these Anthropic Claude 3 models. So this is different than the original Claude 2 models. And what it essentially does is when it's a streaming response, you'll notice that you're getting these content blocks, you're getting this delta that's telling you here's what the text is. So this is essentially the output that we want. Okay, in order for us to deal with this and actually stream this back, unfortunately we can just stream it back if we wanted to, but the problem is it's going to be messed up like that. So what we have to do instead is we actually have to create, have to transform it. So I could write that, but I already have, so it's kind of crazy to write that again. So the first thing we need to make sure we have just somewhere in our application here is we do need to bring in the decoder. So we'll bring in a new text decoder. I think they can be UTF-8, I don't think it matters. And then we have this transformer function that I will show you in 1 second. I'm going to copy and paste over here just so we can see it. We'll go through it so we can understand what it's doing. Okay, so this is a transformer function. It takes or creates this new transformer or transform stream that takes in a transform function, and that transform function takes in a chunk and a controller. We use the decoder. Sorry, my dog's barking. We use the decoder to decode the chunk that comes in as it's sending those through. And then we can parse those into JSON because it returns those JSONs back to us. And so this is just a little note, like this is how it's coming back. So we want to make sure we parse that. All right, and then what we're going to do is we are going to see if the event type is content block delta, if the delta type is text delta, and there is text. We're going to go ahead and enqueue that on the controller. Buffer is not there because we don't have our node types, so we will just do install at type/node. Yeah, at types /node -d. So we now have that, and that should disappear. There we go. All right, so now we have this transform stream on this a variable we call transformer, and then what we can do is when we return this body here, we can just pipe this through the transformer. This is going to yell at me because it's going to say that it's possible. What's it saying? That is definitely right. It doesn't know if the response.body exists. All right, so this should work. Let me just try this, and then we can fix this in a second if we need to. So we refresh this, and assuming it doesn't yell at us, service unavailable. Okay, so we get some sort of error. Let's go see what the problem is. Transform failed with 1 error. Expected that, but because we... Let's learn how to code. Okay, so that should work. This will probably tell us now. That's definitely right. Body. Okay, let's try this one. I'm going to clear this out so we see that. And by the way, that's the other thing. Your errors are going to pop right up there, which is super helpful, so you can see all your log files. All right, refresh this again, and let's see if this works. It's thinking. Here we go. All right, here's a story about a dragon and a knight in 2 sentences. Great. So this worked here. This wasn't great though because it's not actually streaming the response. And part of the reason why it's not streaming the response is because the way that we are sending it back with Hono. So I'm going to go over here and I'm just going to replace this with this snippet of code, which I will uncomment and save. And essentially what this is going to do is this is just going to format the type. This can be HTML, text, whatever we want. We're not actually going to stream this, but just show how it works. And we want to do the transfer encoding as chunked. And this is probably just saying that it's possibly null. So I don't know if we can just do that. No, that's going to just get angry with me. So we probably will have to do, if we want to get rid of that without, we'll just say if response dot body, like this, then we can show this like that. Otherwise, we can return no response from AI. Sure. Okay, perfect. Refresh this now. This should give us that little streaming effect, right? Because it's streaming it down to us. We can do it here. I'll make that a little bit bigger. Do that one more time. Oops, don't know why we just got that. Try that again. Body object should be response body object should not be disturbed or locked. Okay, that's interesting. That shouldn't be a thing. Try that again. What did I do? So it worked, but then it didn't work. Oh, because I changed this. Oh, if response.body, maybe it doesn't like that. Maybe just if response. All right, I don't know why it's doing that. Again, I'm not gonna fight with it. I'm just gonna ignore that for now and see if this works, because I think that was what the issue was. It doesn't like that we're doing something with the body first. There we go. So anyways, all right, so that's working. Again, readable streams and all that kind of stuff. And yeah, okay. Anyways, all right. So we're TS ignoring that just because we assume the body's going to return something. All right. So that worked for us there, but now we actually want to do the image thing. We actually want to bring back or actually have it do some work with an image. So what I'm going to do to make things super easy is I am going to copy in an image that I've already encoded as base64, just so that we can test this. And we're going to basically say describe what is in this image. So we'll start with that, and then I'm going to go ahead and grab this file over here. All right, and this is going to be this big, big, messy chunk of base64 encoded data. I'll save that, that'll sync, I'll come over here and refresh, and then this should now stream back. This image depicts a golden retriever sitting on a sandy beach during a sunset or sunshine, all kinds of information. Okay, I know you don't see that image, so it's probably hard for you to, to envision that, but this is the whole point, right? So this is explaining exactly what's in an image, and if we want to verify this, we can try with another image, which we'll do in a second. So we'll get there. All right, so here's what we want to do. We want to basically take an image, convert it into base64, feed it into this model for us, and then automatically have it generate the information about the image itself. So here's what we're going to do. We've got about 22 minutes left, so we're going to see if we can get all this done in 22 minutes. And if you have any questions, comments, or whatever, please throw them in the chat. Okay, so here's what I'm going to do. I'm going to start by removing this image because we don't need that right now. So we know that it works, right? We didn't see the image. I should have kept a copy of that image. Oh, maybe I can. I wonder if I can convert. I guess I could show it in the browser. Would that work? Hold on. Let me just see something. If you did this, but you did. Hold on. Base 64 image in browser. Let's get that first bit. You want this. We need this. Let's see if this works. This could work. Who knows? It's quite possible. There it is. Look at that. Genius. Okay, so that's the image that is being described here, which is pretty cool. And I use Stack Overflow and not ChatGPT. How about that, Stack Overflow people? You're still useful out there. Okay, so anyways, so that's explaining that. That's the image that we used. Perfect. Okay, now what we want to do is we want to just take any image, and we're going to go ahead and use that and automatically make that work as part of our part of our workflow process. So here's what we got to do. A couple things. First, we want to go ahead and use something called, because we need to be able to store the image so that we can convert it and have the original image and so forth. Now, there's a couple different ways we could do this. We could scrape our website or look at all the files and say, find any image tags. We could do that with AI. We could do that with some other search algorithm. Pull back all those URLs of the images, run it through, check the ones that don't have alt text and so forth. That's all. We could do that, but I want to show the workflow itself, and we'll do that with a couple of ways that we can trigger workflows with Ampt. So one of the things that we have with Ampt is storage, which is a direct interface into S3, but it just manages all the complexities for you, so you don't have to worry about those complexities. And essentially what we can do is we can define a bucket, right? So we can call it whatever we want. We also have the ability to do public objects. So if we use a bucket called public, then anything we put in there will automatically be visible for us. So here's what we're going to do. We're going to go here, and what this says, by the way, is that we need to use this storage interface from the SDK. So we'll come over to our code, and we're going to pop in this here. So now we have the storage thing, and let's go ahead and create a thing, and we'll call it const image uploads. And this will be storage, but we're going to call this storage public like that. Okay, so now we have a public storage for our image uploads, or we have a bucket called public, which already exists, but it's already there, but we've now mapped it to image uploads. So we're going to come down to the bottom of our code here, and what we're going to do is we're going to say image uploads like this, and we're going to do a listen. So I'm going to say on, like that, and then we have the option to listen for everything when a file is copied, when it's removed, or when it's written. So I'm going to use write, and then I'm going to come over here and do async, and this will load as event to start, but I'm going to call this file, and then do this, and then I'm going to just log out file, uploaded file. Okay, so this is all I've done. All I've done here is just create this public mapping here by bringing in this interface, and then just have this image uploads on write do this particular thing. All right, so here's some cool stuff. I can type in open in my CLI. This will bring me into my, oops, I'm gonna have to log in, do that. This will bring me into the alt generator. This is the app that I'm using. And then again, it's going to show me all the different environments that I have. So this sandbox is just my environment right now. I haven't published this to production or anything or created any previews. So this is just what we have now. So I'll click into this. And this is going to tell me how many invocations I've had, all kinds of stuff, gives me my logs, detailed logs. I can search these logs. I can do all kinds of things. I can filter them and say, just show me the HTTP logs, just show me the data logs, things like that. So again, super helpful to search and find issues. If I click on this to see this error, for example, it'll give me, the detail of that error. I can thumb through them and whatever. Okay, so I have, what do we want to do? We wanted to go into storage. Okay, so now we go into storage, right? And the only thing I have in storage right now is just this public folder, which is automatically created by default. And now we want to upload something to that folder. So click upload files. I have a bunch of images that this must be from the last project that we did. We did something with image. Oh, we were doing our resizing of images in an earlier live stream. So these must be those. Okay, so these are just some images here. So let's go ahead and grab this one, and I'll click open. This is a little off-the-shelf package that we have for our storage maintenance here, which is not great. We don't love it, but it does work. So anyways, we uploaded this here, but what is important is to go back and see what we get for a log. So this says there was a storage change and a file was uploaded. It was written. Here's the path to it, and here's the size. So now we have this bit of information that we know an image was uploaded. Okay, so that's the first step. We didn't have to set up any triggers or anything like that. We just wrote a snippet of code that said on, and it hit it. Okay, so let's go back to storage here. Because the other thing that we want to do is, now that we know that a file was uploaded and we know the name of the file or the path to the file, we actually want to get more information about it, right? Because we need to know what kind of file it is. We need to know the meta type and so forth. So there's this file information and metadata that we can get by just calling stat on it, okay? So let's go over here and we're going to change our code here and say, rather than just file uploaded, we'll keep that, but we're going to go ahead and say const stats equals await, and this is going to be on the image uploads, and we're going to use stat, and then it's going to be file dot path like that, because again, this is the path, and this is already going to know it's in our public bucket. And again, you can do, you know, as deep a path as you want to. It's just a different way to describe the image with how S3 works. But so now this is going to give us some stats. So I'm going to go ahead and I'm going to log out what it tells us about these this file. So file stats, okay, save that. I'm going to go ahead and clear this out. All right, and then we'll go back over here to this storage, and I'm going to upload a new file, and we'll upload, I don't know what that one is, but let's upload it. Okay, so we're uploading another file now. That file's uploaded, and if we go back over to here, we will see, hopefully, that we have a file uploaded called image5290.jpg, and then the stats tells us when it was last modified, the size of the file, any metadata that we associated with it, and super important, the image type, which we're going to use when we actually run this through the model itself. Okay, so now we have the file. We know the file exists, and by the way, the file is saved. We also know that the type of file that we have, and so now we want to actually read that file and convert that file into a base 64 string or whatever, I guess. So, all right, so we're going to do const, and we're going to do, we'll just call this image, I guess, and we can do await and image uploads. And now if we go here, I'm going to go back to the storage documentation, we have read files. So there's two different ways to read files. You can either read them as a readable stream, which is something that, again, you can stream that image if you wanted to do it that way, or well, not stream the image, or whatever the file is. So if it's a text document or CSV, you could stream that information out, or you can just read it in as a buffer. So we just want the whole image because we want to convert it. So we're going to read it as a buffer. So the option is to either do read with the file path and then buffer true, or you can just do the read buffer that way. So let's do that. So we're going to do image, and we're going to do this image read buffer, and not bugger. Try that again. Read buffer. All right, so now this will go ahead and read the file path and bring us back a file called image with the, as a buffer. Okay, but the thing is that that is a buffer, and we need this to be base 64 encoded. So I believe if we were to just do image dot to string, then we could just base 64 encode it like that. I'm 95% sure that's the way that it works. Let me clear this out. All right, so I'm going to go back over to our storage here, and I'm actually going to delete these two files. We'll upload them again in a second. All right. I'm going to refresh this because I never know that this is always janky a little bit on us. All right, so let's upload this file here and click open. Again, not great. So this has uploaded this. So this should come over here now and say that the file is open. And did it image to string? Did that not work? Let's see. Were we not saved in time? Image JPEG. Image, read the image, read the buffer, file path, image to string base 64. That should have worked. The other thing we can always do too is you can always check the logs in the last 5 minutes or so and make sure that, so storage remove, we got those. This was the one. Okay, well, let's try it again. I don't know, maybe we weren't saved in time or something. Going to public. And I'm going to go ahead and upload another file, and we'll upload this one of the dog. Open, uploading, uploaded, and this should fire off a few different things. We're not getting this to work correctly, so let me just double check and see if I did something wrong, because I probably did. It's almost always a skills issue. Let's see. So we want to make sure that we read the buffer and then toString base64. So why is this not? So this is await, and we are async, right? So we should get this file path. Well, let's do this. Let's log the image, and rather than logging it toString, we'll just log the image itself and make sure that we're actually getting it. All right, let's try this. Let's log out the buffer and try that. Upload files. All right, let's grab this one, hit open. And that was loaded. Okay, we get the buffer there. So we are getting the buffer. Console log image.toString. We don't need to await that, right? ToString. I don't think we have to. Image, so image uploads, read buffer. We're getting the buffer back. So we have a buffer stored as image. And then we output the image, and that works. But this is an output. I was going to say it's possibly undefined. Yes, we know. I get it. All right, well, this should be working. Maybe all right, I'm gonna try it one more time. See what I'm missing. Oh, I just uploaded the same file. Okay, so for some reason that toString is not outputting anything, which doesn't make any sense. All right, I don't think it has anything to do with those files. Just literally not executing that string of code. The thing I should do here, just to make sure we got plenty of time out. So make this like 60 seconds. It's going to yell at me. Doing some things wrong here. Okay, async file, good. Okay, so the file's uploaded. We know it's there. We can read the image. We've got the image in a buffer here, and we should be able to convert that buffer to a base 6, which is really weird that we can't. So let me try this maybe. Let's go to, I don't know, we'll go to Google. It's I don't want to search for dog on a beach again. How about cat in a tree? And we'll go to images here. All right, so here's a cat in a tree. Let's save image as, and let's just put this in, I don't know, I guess desktop, something like that. No, that's not what I want. Downloads, too many things going on here. Get creative. Let's see. I guess we'll just throw it on the desktop as image cat. All right, so now we have an image cat there. Let's see what happens if we upload the image cat. Where was I on my desktop? Image cat, open. All right, so that. Image cat, okay, I don't know, maybe, oh, you know what it might be? It might be, I had problems with this before. It might be the encoding of those images because I copy them right out of photos on Mac. So that might be it. Okay, well, anyway, so this is giving us what we want. So I don't know why that image is causing some problems. Those other images are causing problems, but apparently we're not going to use those. All right, anyways, sorry, we wasted a whole bunch of time on that. All right, so this works. So now we have this here. So let's go ahead and take this information and we want to run it through our the algorithm in order to describe the image. So here's what I'm going to do, only because we're running super low on time. So I created a let's see here. Copy this over so that we can get this. And I was trying out different models too, so I have a little bit of extra stuff here. But all right, created a function that is just called describe image. And essentially what that does is it takes the image, which is going to be the base64 encoded version of it, and it takes the image type, which is going to be image/JPEG, for example, and then we pass in that same amount of information. I just put this system thing here, your helpful assistant for the blind that describes images on websites. Please make your description as detailed as possible, but keep them short enough to comfortably fit in an HTML images alt tag. And then I just have it, the base64, the image type, the image, and then just the text is describe the image. And then I was trying it with Haiku versus Claude Sonnet. So that goes ahead and it will generate that description for us. So I can go ahead here and rather than just reading this like this, we'll actually call, we'll say const, I guess we can call it response, describe the image, which will take the image and convert it to that. It'll use the stats dot, it's just type, not content type. And that'll give us the response. So now we have this response. And then the other thing we need to do is, and this is something I said earlier in the stream, so we have to convert this stream back to text because we actually just want to take this text and do something with it. I actually just typed this into ChatGPT and it was super helpful. Was just this function here that it created for me called read stream as text. So it just takes in a readable stream and then it just does the text decoding for us and then basically just spits back the results. So what we can do there is we can describe the image and we should be able to, let me just get this here, is, let's see, describe image right, stats types, we'll get the alt back. Did I put that in here? No, I didn't. Read is, all right. Okay, sorry. Okay, so then what we can do is this will spit back the response for us, which will come back as a readable stream. And then we should be able to, what is this saying? It's not assignable to type string. ToString is not assignable to type string. Okay, well, I'm going to let that go for now because we're running out of time. But this should work. So then I'll take the response.body, we'll pipe it through that transformer like we already did before, and then using that read stream as text, and then we're going to go ahead and we're going to log the output, which we will call the description, like this. Okay, so this should all work now. Again, this, I guess this says it could be string or undefined, right? I guess so that we could, if we want to, we can just do this to make that work. And then this could be stats or undefined. So we'll do string or undefined. I know this is not great stuff here, but this is possibly null, right? So I think we can, I don't know, I'm going to say response.body. I don't want it to mess anything up on us. All right, so let's just do that. Okay, so this should all work. This should output that for us there. We don't want to output that long string there. We don't need to output the stats. All we need to know is the file was uploaded, and we want to spit out the description. So let's go ahead and find another cat in the tree picture. Let's do this one, and we'll save image as cat2. And then we'll come over into our system. I'm going to clear this out. Come back over here to storage, and we're going to upload a new file, and this is going to be cat2. And open. All right, so this should upload that file, should detect that it was there. It should run it through the image detection by converting it to base64 and then giving us the description. So this says the image shows an adorable red squirrel perched on the branches of a bare tree. The squirrel has a fluffy reddish brown coat. Well, I don't know if I'd say that was a squirrel, but again, you know, I guess it only does so well. So let's try one more maybe. Let's try this one. Oh, that's a video. But we can save image as, let's try this, cat3. Okay, jump back over here. Actually, I'm going to clear this out. And let's do this. And we will upload cat3. JPEG, hit open. And now we should get that, and it says readable stream is locked. Okay, so every once in a while we are going to get weird errors like that. Let's try that one more time. Delete files. Upload that again. Again, we can retry these things. We could put all kinds of stuff like that that would do that. I don't know if that is uploading. That probably didn't. It didn't. All right, so upload cat3, open. Okay. I don't know why it's locked. Something I'm probably doing. I'm sure if I save this and sync it and then try it again, it'll work. All right, one more time, and then we're done, I promise. Remove file. Where's delete files? Okay, delete that file. Refresh this again. Maybe it's that file. Again, there's all kinds of reasons why some of these things might not work. It's retrying cat3. Saying the readable stream is locked. I don't know why. Let's try one more time with a different image. Let's try that. I think it's going to keep retrying that too until it... so let's actually do... put a quick bit of logic in here so that if it fails, let's log the stats so that we can see those, and we can say if image here, then execute this snippet like this, save that, and then else log. No image found. Okay. File stats, that, blah, 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 blah. And that's what we wanted. I think that's what we wanted to do. Now, I guess we're going to have to do a try catch here too. So try. And if it fails, it fails. So we're just going to say catch E log error. Okay, we'll try this, and then that way, if it fails, it fails. Not the end of the world. Okay, let's find something else. Well, I guess we can go with another cat in a tree. Let's find, how about this one? So wiki common, so we're not violating any issues. So this is going to be cat4 here. We can double check this as well. Okay, and let's go storage, upload, cat4, open. All right, this one, cat4, description of adorable kitten claim tree branch. Okay, so cat3 reprocessed, and that time it worked. So we must be locking the readable stream somehow. Maybe not calling done on it or something, I don't know. Anyways, readable streams. So that's essentially the idea, right? So you can just upload an image into the system. Again, figure out why the readable streams are locking themselves. Again, I'm sure that's a skills issue on my side. But anyways, it is pretty handy. And you can use this. And then again, we're not doing anything where we're saving these, but honestly, maybe we'll pick up on this. I won't be around next week. I will be in Belfast at Serverless Days Belfast, but maybe pick up on this maybe the following week, and we can take this and actually we'll put them into a database. We'll be able to show them on the website, or show them, list them with their description along with the image next to them. There's a whole bunch of things we can do. And again, but very cool stuff. Super easy to use. Again, if you know JavaScript, so feel free to use ChatGPT to ask some questions as well around processing some of this stuff. But anyways, so sign up for Ampt, give it a try. It's free to start. You can play around with some stuff, and we would love your feedback. So. That is it for today's stream. Hopefully this was interesting and useful. There wasn't much of a massive wow moment there at the end, but it's cool stuff. So would love to hear from you, and sign up for Ampt. And we'll see you next time.